Good morning, friends. I am Yashwant Kanetkar. In this course, so far we have seen two block ciphers. Both of them were for symmetric encryption and decryption. One of them was RC2 cipher, and last time around we also saw the data encryption standard cipher or the DES cipher. Today we are going to discuss what is known as a triple DES cipher. This also happens to be a block cipher used for symmetric encryption and decryption. First thing that we need to understand is why is it that we have to make use of triple DES. The reason is simple. The DES algorithm that we saw last time around, it is vulnerable to brute force attacks. Brute force attacks means when you use a 56-bit key for encryption in a DES algorithm, people can try a variety of combinations of that 56-bit key to be able to decipher from the cipher text the original plain text. So whenever people attack a ciphering scheme or encryption scheme, they would try to make use of all possible combination of the keys out of the 56-bit key, and this is something which can be done using computer. It can also be done using some specialized hardware. Since DES was found vulnerable to such brute force attacks, hence triple DES came into existence. The solution that was suggested was to enlarge the key space, because if you take a 56-bit key, then the maximum number of combinations that you can make out of it would be 2 to the power 56. If you expand the key space, if you make the key space bigger, in that case the number of combinations would grow, and if the number of combinations are too many, then these brute force attacks would not be feasible. What was earlier suggested to enlarge the key space was to use what is known as a double DES algorithm. However, this was also found susceptible to what is known as a meet in the middle attack. Now, brute force attack, meet in the middle attack is only some of the varieties of attacks that can be made. There is a large variety of these attacks, and all of these fall under a category known as crypt analysis. In the later part of this course, we have a dedicated lecture to crypt analysis. So at this juncture, I would just say that the DES algorithm was found to be vulnerable, so also was double DES. That is why triple DES came into existence. Details of brute force attack or meet in the middle attack, we would postpone it till that crypt analysis lecture. In triple DES algorithm, the DES algorithm is used 3 times. Let's see how. The order of operations that are carried out are not encryption with one 56-bit key, another encryption with another 56-bit key, and yet another encryption with another 56-bit key. Instead of that, the sequence that is followed is EDE, means you do encryption, following that you do the decryption, and then you again carry out the encryption. To ensure that there is interoperability with the DES, people at times make sure that K1, K2 and K3, all of them are equal. This is just to ensure interoperability with DES. Means if somebody has encrypted a file using DES and you are trying to decrypt it using triple DES, you would be able to successfully carry out the decryption only if in all the 3 rounds you make use of the same key. So to ensure backward compatibility with DES algorithm, K1, K2 and K3, which are keys used in the 3 different rounds, to be equal, if you do that, then interoperability with DES can be ensured. At times, if you are encrypting using triple DES itself, then you need not use K1, K2 and K3 to be same. Instead, you can use different keys for each of the encryption, decryption and encryption rounds. If you keep K1, K2 and K3 same, then that becomes the weakest implementation of triple DES, because effectively your algorithm becomes only the DES algorithm. Now triple DES is very popularly used for electronic commerce. In the electronic payment industry, lot of applications are still making use of the triple DES algorithm. In addition to that, there are appliances that are used in virtual private networks. Similarly, cellular networks or data networks, they also make use of triple DES algorithm extensively to maintain confidentiality of the data. Because ultimately, whether it's RC2 or DES or triple DES or double DES, idea is that the data should remain confidential. That is something which is primary, and all these algorithms permit this to varying number of extents. Triple DES is found to be much better than DES or double DES. Now when triple DES encryption and decryption is done, realize that the rounds that are there, there would be 16 rounds while encryption, 16 more rounds during decryption, and 16 more rounds during encryption. So in DES we had seen that there are 16 such iterations or 16 such rounds. In this case there would be 16 into 3, that is 48 different rounds. In the first set of 16 rounds, what is used is key 1. This is also a 56-bit key. In the second set of 16 rounds for decryption, again a 56-bit key, but a different one, that is K2 will be used. And in the third set of 16 rounds, you can either use K3 or you are also allowed to make use of K1. It's your choice. Ultimately, it's a block cipher, so 64-bit plain text would be taken and 64-bit cipher text would be emitted at the end of this 3 rounds of triple DES. During decryption, exactly opposite would be done. 64-bit cipher text would be taken and what would be outputted would be 64-bit plain text. The order of course had changed. While encryption we used encrypt, decrypt, encrypt. That was the order. Whereas while decryption, naturally it should be decrypt, encrypt, decrypt. So EDE is for encryption, whereas DED is for decryption. Now working of triple DES is simple. You put everything or the plain text through the 16 rounds for encryption, another 16 rounds for decryption, and yet another 16 rounds for encryption. M in this figure indicates message, whereas C indicates the cipher text. Message text means the plain text, and cipher text is your encrypted text. In this figure, K1, K2, K3 are 3 different keys, but as I said, it's your choice whether to keep keys same, different, or partly different. For example, you can use K1, K2, K1, where for first set of 16 and last set of 16, the same key can be used, whereas for the middle set of 16, you can think of making use of a separate 56-bit key. The sub-key generation for each of the round, that process is exactly same as DES. The Fistel function that we had seen, that is also exactly same as DES. The substitution boxes, the initial permutation and the final permutation, all of that remains same.